Hello, Stormwater designers. Welcome back to Clear Creek Solutions instructional videos. It's another FE exam review problem going over hydrology and water resources practice. This one, we're going to look at discharge in a rectangular weir. I'm your instructor. Quickly about Clear Creek Solutions, we do software development, hydrology education, and clinics, as well as stormwater analysis and facility modeling projects. So if you're interested in that, check us out at our website. But let's get into the FE exam review problem. This problem, we're going to talk about find the discharge, CFS, in a rectangular weir with a length of 3 feet and a head of 0.75 feet. And there's the options for the answers down below. So first thing we're going to want to do is identify what we have given in the problem, what do we need to find, and then what equation can we use to find those variables. So the first thing we're going to do is identify the given, which was the length of the weir. We have that. We have the head or height of the weir as well. So those are two important components, but we're going to need C and Q based off the given equation to finish this problem. So I searched in the FE handbook for weir formulas. You can do this using Control F if you're practicing. If you're on the test as a search bar, just look for rectangular weir and you should be able to find it. Here's the formula: free discharge suppressed, Q equals CLH raised to the 3/2. That's the formula we're going to use. So we have the head, we have the length, but we need Q and C, or specifically we need C to find the discharge. So here's another excerpt that was just down below. For rectangular weirs, C is 3.33 for USCS units. We are in USCS units, so that is the coefficient we're going to use. If you're in SI, we use a different coefficient, and if we had a V notch, well, then that would also be a different coefficient. But the problem's in USCS units because feet were given, and need to find C, which is 3.33. So we have that step. L equals 3 feet. The head, or H, is 0.75 feet. Now we can just plug that right into the equation to find the discharge Q. So we've got 3.33, that was the coefficient, times 3 feet L, times 0.75, remember, raised to the 3/2. So not just 0.75 for the head, we also need to raise it to that 3/2 power. And our answer we get is Q equals 1.622 CFS. So we can deduce that the flow Q is 1.6 CFS. And if we look at the answers given here for the problem, we get 1.5, 2.5, 5.0, and 10. I just want to point out that for basically all of the FE problems, you're not always going to have the exact answer available. Sometimes the answer is pretty close, and you just sort of need to deduce that they want a certain answer. When it comes to problems where they're asking about what is the minimum required, sometimes you're going to need to aim for the higher value. But if you're more than 10%, 10 to 20% off of the value that you got in your problem, you might not want to pick the closest value. You may actually have a problem in your calculation. So just keep that in mind. But for this problem, our answer is A, 1.5 CFS. Now, if you're struggling to study for the FE exam, specifically the water resources section, we have a free guide for you in the description box. Just click the link down below. You can download that free guide. It'll give you some example problems, some things to look for when answering water resources questions on the FE exam, and hopefully that'll help you pass the FE exam. So we're Clear Creek Solutions. Thank you for watching this video, and we'll see you guys next time.